In this video, we're going to cover Learning Objective A, and I'm going to show you how to find exact values of sine, cosine, or tangent using what's called the Pythagorean identity. Now, if you think about how Pythagorean's theorem works, that's just a squared plus b squared equals c squared, where c is across from the right angle, so that's here, and then a and b are the two legs. Well, if we were to take this right triangle here and superimpose it into the unit circle as such, and if we look at the angle movement by this ray here and we call it theta, which is right there, what we can understand is we can actually see what side length A and B really are. Remember, to land on this point on the outside of the circle, what you would do from the origin is you would move right and up. Remember, this right movement is the x movement we call x cosine. So this leg here on the triangle is this one. So really, this a value becomes the cosine of theta. The same fashion, moving upward, was the y value or the sine value. Therefore, b is the sine of theta. And this triangle is embedded in a unit circle, so the hypotenuse here is the actual radius of the unit circle, in which is 1. So if you replace a, b, and c with cosine, sine, and 1, what you end up getting would be cosine of theta squared plus the sine of theta all squared equal to 1 squared. Now when you simplify this, what you're going to end up getting is this final identity here. And I want you to notice the notation. Here I have cosine theta all squared in parentheses. Now what you don't do is you don't simplify this and you write it as cosine theta squared, because that actually looks like you are squaring the angle, and that means something else. So that's not correct. How this is actually written is in this format. The squared goes in between the word cosine and the theta. Now sine squared, or sine theta squared, is the sine of theta squared. 1 squared is 1. So we can actually use this Pythagorean identity now. It is very helpful to use when they give you cosine and they ask you for sine, or if they give you sine and they ask you to find cosine. You can also use this theorem if they give you, for example, the cosine value and they want you to find tangent. Don't forget that the tangent of theta is sine over cosine. So if we have the cosine value, we can plug it in here. How can you find the sine value? You can use this formula. Now let's just review notation really quickly. Which of these two expressions are equivalent to each other? Remember, letter B we don't like, because B looks like we're actually squaring the angle. That's not the true one. This and this is equivalent. So make sure when you write this, you either do the first format or the second one. This first one here, though, is the most common. Okay, so let me show you this. They are telling us in here that the sine of some angle is equal to 0.6. Now, what does the sine of some angle mean? Remember, the sine just means the y value. So what this actually says is, hey, the y value of some angle is 0.6. So they actually just gave me this particular bit of information. That's exactly what this says. Well, where does this happen on this graph paper? Well, I don't know if I move left or right, but I know I move up 0.6. Well, up 0.6 would actually land me right here. So then the question is, do they want me to move to the right and land here on the circle, or do they want me to move left and land here on the circle? I don't know. So let's just identify both. So this ordered pair is something in 0.6, and this ordered pair here is something in 0.6. So really there's two possible ordered pairs to find. Either this angle right here that goes from there, that would be the theta, or do they want us to travel over and find this particular angle? Now, how do we do that? Well, if they give you either sine or cosine, we can find the other. Pythagorean's identity just says cosine squared theta plus sine squared theta equals 1. So sine is 0.6, so I'm going to put that in here. 0.6 squared, and it's cosine squared theta. Now 0.6 squared is going to give us our cosine squared theta plus 0.36 equals 1. We can solve and get the cosine of theta by itself. First thing we would do is move the 0.36. So we'll subtract that from both sides. That's going to leave us with cosine squared theta is equal to 0.64. How do you get cosine by itself? You take the square root. Now, be careful, this technically is a quadratic, it's squared. So really this is where we have either plus or minus. That's where the two different answers come from. This will be the plus side, this will be the minus side. So this becomes the cosine of theta equals plus or minus 0.8. Now does that make sense? Look at the graph paper. If I go to the right, 0.6, they're thinking I'm going to go up roughly 0.8. So this is be 0.8 here, and this would be negative 0.8 here, because I'm moving to the left on this one and the right on this. Let's look at another example. This time they're telling us the cosine of an angle is 3/5. Remember what cosine means. That means the x value. So really what they're telling me is they have an ordered pair and they know that the x value is 3/5. They don't know the y value. Well, where could that be on the circle? Well, if the x value is 3/6, that's about 0.6, so it's about right here. Should I go up and land there on the circle? Or should I go down and land here? There's two choices. So it's 3/5 in something, and then also 3/5 in a different value. Now, because we have cosine, they want us to find sine, we can use Pythagorean's identity. Keeping in mind, that's going to find us both the upward movement and the downward movement, so the positive and the negative value. So let's go ahead and do Pythagorean's identity. So cosine squared plus sine squared of theta equals 1. Cosine is 3/5, and I'm going to square it. And we're going to keep this as an exact value. So 3/5 times 3/5, remember. Multiply your fractions, go straight across. So this will be 9/25. Now, I want to be able to get that by itself, so I'm going to subtract 9/25 from both sides. And I'll get sine squared theta equals 1 minus 9/25. To subtract fractions, I want a common denominator, so put this over 1. Just times this by 25 and this by 25. So really, I'll do 25 minus 9, and that'll actually be 16. And then the denominator is still 25. Come in and take the square root. When you do that, we're going to get plus or minus. It's a square root of 16 over the square root of 25. So it's equal to plus or minus 4/5. The plus part is the moving upward 4/5. The minus part is what if we move down the 4/5. So there are two possible answers for this. Now I do want to show you a second way you can do this type of problem without using Pythagorean's identity. It's actually a pretty clever geometry trick. So let's look at a fresh slide. Now what I'm going to do this way is I'm going to actually use the acronym of Sohcahtoa on this example. Now this way will also give you the correct answer for the sine of theta. Here's what I'm going to do is revert back to geometry. If the cosine of theta is 3/5, remember what cosine stands for. Cosine of theta would be the ca, or adjacent, over a hypotenuse. So if this is our angle, and this is the fraction here, I'm going to jot down that this was 3/5. So on here, the hypotenuse is the 5, the adjacent side to the angle is 3. So the hypotenuse is across from the right angle, so that's 5. Adjacent means you touch, so that's 3. Now, if they want us to find the sine, we know sine is OA. So the sine of theta is opposite over hypotenuse. We already know the hypotenuse, it's 5. But what's the opposite side? So really, I need to find this right here, and I'm going to call that y. Can I find side length y? Sure, I can use Pythagorean's theorem. I would say 3 squared plus y squared equals 5 squared. So 9 plus y squared equals 25. Subtract 9 from both sides. So y squared equals 16. And then take the square root. So y in this case equals 4. And remember, this is quadratic, so I could put either a plus or a minus 4 in here. So that's why it's plus or minus. So then I'm just going to take this value and put it in for there. So the sign is either plus or minus 4/5, which is what we came up with before. You're more than welcome to use this method for finding the missing sign or cosine instead of using Pythagorean's identity. Now I do want to go one more step further. What if I asked you to find the tangent of theta? Now remember, tangent in Sohcahtoa means opposite over adjacent. So a very easy way to find this, if you have the triangle, we found this y side, by the way, was either plus or minus 4. So tangent opposite over adjacent, opposite would be 4, adjacent is 3. So it's either 4/3 or it's negative 4/3. They would have to be specific and tell me which quadrant they're looking in. If they're looking in quadrant 1 versus quadrant 4 would make a difference on this. Another way you can find tangent if they had you to do this method is if you found cosine before, which they told us was 3/5, and then you did the work to actually find the sine, what you could do for tangent, since tangent is sine over cosine, you would just fill in the sine, which is the plus or minus 4/5, and you would divide by the cosine, which is 3/5. To simplify this, you just multiply by the reciprocal of 5/3 and 5/3. This will all cancel, and you're going to be left with plus or minus 4/3. So there's really two ways to find tangent. Either use the fact that tangent is sine over cosine, plug in the sine and plug in the cosine value and simplify, or draw the triangle. Remember, tangent is opposite over adjacent. Find the opposite in the adjacent side and plug it in.